Hey everyone, and welcome to a deep dive that's, well, tailor-made just for you. We're shining a light on optoelectronic engineering today.
Ooh, I like what you did there.
Yeah, thanks. But seriously, you're clearly interested in this field, maybe a career move, maybe just pure curiosity. And based on what you've shared with us, we've crafted this deep dive to hit all the right notes. Speaking of hitting the right notes, we've got a real expert joining us today.
Hey, everyone.
Now they have this incredible knack for taking even the most complex ideas and making them crystal clear.
I try.
So buckle up, everyone, because we're about to demystify optoelectronic engineering. So let's start with the basics. What exactly is optoelectronic engineering? In a nutshell, it's where the magic of light meets the power of electronics.
It's like the love child of optics and electronics.
Exactly. And we're not just talking about your grandma's light bulb here.
No offense to grandmas and their light bulbs, of course.
Of course not. We're talking lasers, LEDs, fiber optics, the kind of tech that seems straight out of science fiction.
And the really cool part, it's not just cool, it's booming. We're talking a projected global market of, get this, $24.9 billion by 2027.
Billion with a B. That's huge.
Yeah.
What's driving that kind of growth?
Well, think about it. Optoelectronics are everywhere. That smartphone in your pocket, lasers and sensors, life-saving medical imaging at the hospital. Optoelectronics again.
It's like optoelectronic engineers are the wizards of light. But what's it actually like to be one? Do they wear pointy hats? We'll find out right after this when we take a look at a day in the life. So, pointy hats, not so much.
Yeah, you can leave those at home.
But safety goggles.
Definitely a must-have.
Now, when you picture an optoelectronic engineer, you might imagine someone huddled over a workbench in a dimly lit lab.
Surrounded by wires and circuits.
Right, like some kind of mad scientist.
Well, there might be a little bit of that.
A little mad scientist in all of us.
But in reality, it's much more collaborative than you might think.
Oh, really? Tell me more about that.
You're working with a team of brilliant minds bouncing ideas off each other.
So it's a real team effort. Absolutely.
And I bet those aha moments are pretty amazing.
The best, especially when you're tackling those really tough challenges.
Speaking of challenges, this field is constantly evolving.
It's true. What's cutting edge today might be obsolete tomorrow.
So how do you even keep up with that pace of innovation?
It takes a certain kind of mindset.
Like what?
You have to be a constant learner. Always curious, always digging deeper.
I can see that.
Yeah.
And not afraid to get your hands dirty.
Exactly. You need that practical experience to complement the theory.
So it's not enough to just ace the textbook?
Nope. You got to get in there and tinker, experiment, push the boundaries.
It's like you said before, those aha moments, they come from trying things out.
And sometimes from making mistakes.
But that's how we learn, right?
Exactly. Embrace those mistakes. They're often the best learning opportunities.
So we've got the collaborative spirit, the constant learning, the hands-on experience. But let's be real for a second. This field is also incredibly competitive.
That's the nature of cutting-edge tech.
Everyone's vying for the next big breakthrough. And those breakthroughs often come with long hours, tight deadlines.
A lot of pressure to deliver.
But for the right person, those challenges are all part of the thrill.
The thrill of the chase.
The satisfaction of knowing you're pushing the boundaries of what's possible.
So you've got the passion, the drive, the caffeine addiction. But how do you actually land that dream job in optoelectronic engineering? How do you stand out from the crowd?
We'll tackle that very question right after this. All right, so we're back and ready to crack the code on landing that dream job in optoelectronic engineering.
It's like we always say, it's not just what you know. It's how you show them what you know.
Easier said than done right, especially in a job interview. You've got limited time to impress.
True. But that's why preparation is key.
So what are some of the make-or-break things that hiring managers are looking for?
Remember those core abilities we talked about. Active learning, problem solving.
Right, those are crucial.
They want to see those skills in action.
So less tell and more show.
Exactly. Think back to specific projects you've worked on. Like that time I built a laser from scratch in my basement.
Well, that's impressive. And all but try to stick to projects that are relevant to the job you're applying for.
Right, of course. So let's say I'm in the interview hot seat, and they hit me with a question like, how do you troubleshoot optoelectronic devices when they malfunction? What's the best way to handle that?
Don't panic. It's a classic question. And it's your chance to shine.
Okay, I'm listening.
Walk them through your thought process step by step. Show them you can think critically and apply your knowledge to real-world situations.
And don't be afraid to get technical.
Exactly. This is where you can really showcase your expertise.
So like first I'd check the wavelength of the laser, then I'd calibrate the photodiode.
See? You're speaking their language now.
Music to a hiring manager's ears.
Yeah.
Now, another question that often comes up is staying current in this ever-evolving field.
Ah, yes, the million-dollar question.
It's like you're constantly racing against obsolescence.
In a way, yes,
Hmm.
but it's also what makes this field so exciting.
True. So how do you show potential employers that you're committed to lifelong learning?
It's all about demonstrating initiative.
Like what? Reading every research paper ever published.
Well, that's certainly one way, but don't forget about professional organization.
You mean like those acronyms I can never remember?
Exactly. Like SPIE, the Society of Photo-Optical Instrumentation Engineers, and IE, the Institute of Electrical and Electronics Engineers.
Right, those guys.
Mentioning your involvement in these organizations shows you're serious about your career.
Like a badge of honor.
Precisely. And it proves you're not just keeping up with the latest trends, you're actively shaping the future of the field.
So it's all about showcasing your passion, your skills, and your dedication to the world of optoelectronic engineering.
Absolutely. And remember, this is a field with incredible growth potential. The demand for skilled engineers is only going to increase.
So if you're fascinated by light and its endless possibilities, if you're driven by challenges and excited about shaping the future of technology, then this just might be the perfect field for you.
And who knows? Maybe someday you'll be the one developing groundbreaking new technologies. Technologies that change the world as we know it.
That's the dream right there. And on that note of inspiration and possibility, we're going to wrap up this deep dive into the world of optoelectronic engineering. A huge thank you to our expert for sharing their insights and expertise.
It's been my pleasure.
And to you, our listeners, thank you for joining us on this journey of discovery. Remember, the world of optoelectronics is vast and full of opportunity, so keep exploring, keep learning, and who knows what amazing things you'll achieve. Until next time, keep those lasers focused.